I was going to put a picture of a Chihuahua there. I don't know why I was going to do that.
I know why you're going to do that, you little shit. Hey, so I guess I don't have to ask you what kind of calls you had this week. I guess I don't have to ask you. Hey, Steve, what kind of calls did you have? What they call about? Because you just told me your week.
That was just the most. That was just the most popular calls. That's just the ones I answered the most by doing it from memory. But anyway, heat exchangers. So tonight, we're not going to talk about piping. We're not going to talk about design. We're just going to talk about heat exchangers. How fun is that? Just heat exchangers.
Loads and loads.
So heat exchangers, what is it that we're looking for in a heat exchanger? We want something that's strong and resilient, something that can put up with pH levels of 1.6, something that can go from 60 degrees to 180 degrees. We're looking for something that can take a lot of cycling. We're looking for something that we as old men can pick up, right? I mean, I got out of cast iron boilers because I can pick up a 110-pound, 150,000 BTU boiler, but I just can't even take off the back of the truck anymore alone a 600-pound cast iron boiler. I just can't do it. Greater heat transfer. We have a much smaller heat surface on these, so we need a much greater heat transfer. Dimension and size is important because people want their basements back. They want to put offices down there because everybody's working from home. They want to put a workout studio there. They want to whatever they want to do. You've got to pick the right boiler for the correct application. This includes doing a heat load on the building. You need to know what your heat load is. Modulation doesn't make up for stupidity. So you need to know whether you're going to be condensing or if you're going to be running high temp all the time. And I'll get back to that in a second. Water quality is extremely important. And maintenance. How much do you want to maintain it? And how often is the customer going to allow you to come in and take care of it? So modulating or modulating condensing. And before I go to that, I wanted to point out one thing I forgot to mention in my introduction. There's a handout tonight. And that handout is a chart, is a sheet of when you start up a boiler, it's a checklist to go over when you do startup. So that's just out there for you guys. Anyway, on I go.
I saw that, Steve, when I was going through reopening up the poll questions because I hit them and I saw that's a nice handout. That's a good one for the guys to have.
Well, you had promised that a few weeks back, and William called me earlier today and said, "Where the hell is it?"
Yeah, that's the one you recently sent me. So that's the one we also used.
So anyway, so let's talk about modulating and condensing, because our boilers are supposed to be modulating and condensing, which is why they come with an outdoor sensor. The contractor no callback mode of taking the outdoor sensor and throwing it away or not using it, that's cheating. That's absolutely cheating. We build boost in all of our machines so you can have boost. But if you only use the modulating, you leave the outdoor sensor off and you let this boiler run 100% all the time at 180 degrees, it'll still be modulating. You'll still be saving good money. But if your return temperatures are above 130, it's no longer condensing. So you've officially put in a modulating 89% fan forced boiler. That's all you've done for the people. But modulating condensing is when I can have return temperatures below 130, which will then take our efficiencies, like on snow melt, we're getting 99%. We're listed at 95 and 96%. But you'll get 99% when you're reducing that cold water to it. And it just gives the customer the maximum efficiency for what they paid for. Plus, it's easier on the boiler. Plus, your boilers will stay cleaner. And it doesn't matter what it's made out of, it'll just stay cleaner. But now what I want to do is look at materials that we make or that the industry makes condensing boilers on. Now, this will surprise some of you, and I'm going to go through each one of them separately, but I'm just going to introduce them right now. There's cast iron condensing boilers, there's aluminum and copper hybrids, and there's stainless steel. So poll question number 2, Jason, if you would, please.
I'm on it, Big Daddy. Here we go. Woo! Let's move it out of the way. When installing a ModCon boiler, I prefer a heat exchanger made of the following: cast iron, just like my dad used. I like that. Aluminum and copper hybrid. Stainless steel is the best. That's true. No idea. That's why I'm here. Sorry, that's pretty good. That was
Now
pretty good.
we want to try to be a little politically correct tonight. So
That was pretty good. That's funny. 6% say cast iron like my dad. That's pretty. 78. Holy moly, holy. 79. 79 say stainless steel. The best. Damn straight all day long. 16% said no idea. That's why I'm here. All right, we got a couple more minutes, a couple more seconds, and
I was going to say a couple more minutes, dude. I won't be
yeah,
going until
I
9 o'clock
know.
tonight on this presentation.
Couple more seconds. All right. 80% said stainless steel is the best, and they are correct. 5% said just like my dad, and 15% said no idea. That's why they're here. Well, thank you for coming tonight. Go ahead, Big Data.
All right, so let's look at cast iron. So who was that? Wow, that was
So rock
loud.
on. So rock on, brother.
Oh, okay, thanks. So Greg Super says here in PA, a lot of townships are requiring you to do load calculations. So too in New Jersey and New York, Greg. That's not just us. If you're getting inspected, most inspectors want to see a load calculation because they know if the boiler is 3 times the size it needs to be, it's only running at 30% of its rated efficiency, which is horrible. But anyway, let's go on and look at some heat exchangers that are on the market. Maybe you've seen it or not. There's actually a condensing boiler out here in cast iron. And they did that because, well, the typical atmospheric boiler you guys are used to was 600 pounds and cast iron. And so they came out with an 800-pound condensing boiler in 200,000 only size. It's made thick. I mean, it is thick. The cast iron is an inch thick, so the condensate can't rot through it over the term of its warranty. What does that tell you about cast iron and condensation? There's good heat transfer. Has good heat transfer. You just have to heat up 900 pounds of steel first, right? So once you do that, then it has good heat transfer. They're large. This thing stands almost 4.5 feet high, 4 feet deep, and it's only 12 inches wide. But I'll tell you what, I'm going to show you a picture in a minute. It's floor mounted.
Wait, hold on. How tall did you say it was?
4 feet.
So it's almost
4.5 feet. Yeah.
Almost taller than me.
You'd have to get a stool to service this thing. Water quality matters not because it's making iron oxide and doesn't really give a shit. You can clean it, but it's not that easy. I'll tell you what, I took one apart when I had one on my showroom floor, and I got to be honest with you, I couldn't figure out how to clean it, but they say it can be done, and that's what it looks like. It's called the Ray by Mastec. It is huge and heavy, but it's out there. Now let's talk about aluminum, or what we call here as aluminum here in the United States. Anywhere else in the world, it's called aluminum. So great heat transfer. Aluminum or aluminum has the best heat transfer of any metal out there that's in a heat exchanger. Moderately heavy. They don't like condensate. Aluminum and condensate don't go together, and you'll find most of your service calls, when you clean the trap, you're going to find aluminum in the trap. They're harder to clean than stainless steel or cast iron. And here's an example of one, and it might look semi-familiar. If you look here where the condensate, where the shoe is for the exhaust on the right-hand side of that heat exchanger, you see that that's where it rots out, is right at the bottom of that, where the drain comes out, is it rots all around it if you have it in condensing mode all the time. Here's another one. I had to cross out the names to be nice. So heat exchanger materials. Let's move on a little bit here. So
you had to cross out the names to protect the innocent.
Well, yeah, you know that. It's plus that was an old picture that well, never mind. It didn't rhyme with humorous. Anyway, here's a hybrid. So this is a company that actually has, the manufacturer of this heat exchanger actually has a bending machine that can bend 1/2-inch copper in a radius, so it almost meets itself without any fittings at all. They run that back and forth through aluminum. So it's good heat transfer, inexpensive to make. They've proven that by their sale price on the market. They're compact. They're smaller than our fire tube boilers. They're lightweight. They don't weigh much because they're aluminum. The aluminum still doesn't like condensate. You know, even though your water passageways are through the copper, the products of combustion are still going through the aluminum. And
Yeah, but
they're much,
aluminum's susceptible pH. So
that's why I said that. That's why I said they don't like condensate. Yeah. And they're harder to clean if you can clean them at all. Cleaning the flue passageways on this thing are nearly impossible. So, and there's no such thing as a soot stick for gas and aluminum.
Mineral oil.
So here is and actually the mineral oil is not for cleaning, that's for patinaing the aluminum. Did you know that?
yeah, well, don't worry, it burns them off when they're block solid.
So what they tell you to do with aluminum blocks is they actually tell you when you get done cleaning it, well, first spray it with water and burn it to make steam to get the condensate out. And then when you're done that, they tell you to shut it off, let it cool, pour mineral oil down through the passageways and seal it back up and fire it. And what that does, it's like conditioning a cast iron pan. And you're just putting a film on there to try to protect it from the condensate, which is, as I said, we've measured pH down to 1.6, which is extremely acidic. So anyway, heat exchanger material, stainless steel, gotta love it. This is typical of 80% of your modulating condensing boilers out there that are available are made out of stainless steel. Most resilient to acid, very good for heat transfer rate, not as good as aluminum, but it surely makes up for it by being resistant to low pHs. Lightweight, wall or floor mounted units are available. Most are easy to be maintained, and I say that because I'm going to show you a heat exchanger that I still don't know how they call it self-cleaning. So let's take a deeper look into this thing called stainless steel. So here is a product that a company makes all by themselves, and it's a stainless steel fin tube design. And their claim to fame is through the expansion and contraction and the condensate from condensing as a modulating condensing boiler self-washes this unit and it goes down the drain. Of which I'm going to just step back a minute and go, Jason, could you put any light on that for us?
No.
Okay, so then there's the water tube heat exchanger, which if you're not sure, that's where the fire's in that big open area and the water is in the tubes that go around the outside. And then we have a fire tube heat exchanger where the fire goes through the tubes and the water's in the big open area. So you can begin to see the differences between the three, in my opinion, the three stainless steel heat exchangers that are out there that are the most popular today. So the two on the right hold more of the market than the one on the left, much more of the market. So that's where they are. So we determined that these were the two best heat exchangers. And when Kevin was talking 2 weeks ago, we started with the Giannone water tube heat exchanger that's on the left. And the reason we did that is the one on the right wasn't being made and wasn't available in North America. And it was not available to us until the people who had the exclusive on it lost their exclusive on it. That's a story that I'll have to tell you in private over a beer. Might even cost you a scotch or two, because the president of AIC who makes that actually told me the entire story from his mouth. But when that became available to us, everybody got it. We got it, Lochinvar got it, Weil McLean got it. But I'll tell you this, that we buy the ASME style of that unit, which not everybody does. So let's look at the water tube heat exchanger, because this is where the confusion comes in. Should I use water tube or fire tube? Because most of you said you wanted to use stainless. Some of you said cast iron, might have been a joke, but it might have been serious. You might be using the Ray. I don't know. But now let's look at the water tube heat exchanger. So on our Extra Tech heat exchanger that we use on our TRXs, it's one continuous tube that's about a small size, is 150% larger than the Giannone. The Giannone is a series of 9-foot tubes that are headed off top and bottom. The ones behind the insulation, you see that big white strip in the center of that heat exchanger that's cut away between the blue and the red. That's an insulation disc that stops the heat from the front to go straight back. The heat has to go through the tubes first where it gets cool, then wraps around the back to where the return's coming in. So the back is where the condensate is happening. The front is the working end. So, you have flames that are between 1800 and 2100 degrees, taking gas, changing it into flame, taking the flame, taking that same energy that started in the gas and now putting it into the water in the form of heat, and off it goes. So that's how a water tube works. Every one of the water tubes has a divisional plate of insulation in the middle. It's not a target wall, it's an insulation wall. And here's a whole series of them that I'm just showing you, some different sizes. They actually, the one in the top right where it says duo, they actually make a trio that's actually 3 heat exchangers, where the working end is the top and the middle, and the bottom would be the condensing. And this one, the top is the working end, the bottom's the condensing side. So pretty intense. But some advantages of the water tube: they can handle poorer water quality.
Yeah, that's better.
They can handle poorer water quality because of the velocity that we insist to go through them. Fast moving water will not allow things to adhere to the hot surface of that heat exchanger. They can handle higher system pressures, notably from the 200,000 BTU up, can handle a minimum of 165 PSI. Now, most of our water tubes can handle that kind of pressure, over 150,000 BTU. Under that, they're rated to 50 PSI still. But I would say all of our water tubes in our entire offering, whether it be an LX or a TRX, can take a 50 PSI relief valve. Usually costs less to manufacture. There's no welds in this. There's two headers. That's it. Pretty easy. The machine squishes the tubing, rolls it in a joint, puts little dimples on it so it can't squish together, and puts them in a pan. So it's pretty easy to make. The size of the heat exchanger is usually much smaller and usually holds much less water. So there's your advantages. You can also get a water tube because of the velocity. You can get a water tube for heating, or you can get water tubes for domestic hot water. Do you have any other advantages you want to add, Jason?
No, I mean, the other thing is we get rid of that polycarbon shell on the left-hand side. Well, what I'm saying is we get rid of the polycarbon shell with the heat exchange, with the sensor in it, that the fusible link sensor that goes away on the Giannonis. When we switch to the newer Extratech heat exchanger, we get away from that fusible link that's in that heat exchanger. It always seems to be an issue. So you guys see that Uncle Steve showed you the one there, the original Giannoni Semeta, has that polycarbon shell. Well, that we now, our heat exchanger only uses a quarter of a polycarbon base to create the flue outlet, and then the other thing, get rid of the sensor, which is a real problem.
Well, and that really has nothing to do with the actual heat exchanger. We're talking now a safety issue.
I'm talking about the better of the heat exchanger.
That's just the polycarbonate. We don't care. We're looking at water tube versus fire tube. But now let's look at the disadvantages. The disadvantages is this thing will go from cold to holy shit in 10 seconds. There's so very little water in there. I've actually seen these without the proper primary circulator on it, not an NTI, but other manufacturers, floor mounted, jumping up and down on the floor. They must have a high velocity, high head circulator as the boiler pump. If you don't have that high velocity, you guys know that as water spins, it moves faster on the outside of a curve than the inside, right? Right? It moves faster on the outside than the inside. So look at this heat exchanger. Let me zoom in on this heat exchanger real quick. If you do not put the correct circulator on it, if the boiler did not come with an internal circulator like our TRX does, if you buy an LX boiler, you have to make sure you go to the I&O manual and get the correct circulator. If you don't and your velocity is too low, any crap that's in your water like magnetite or calcium or anything else will burn to the inside section of this. Now, let me see if I can get my pointer here a little bit better.
That's
instead
a great
of using instead of using this. Let me get this. See, can you guys see my? Yeah. So right here.
Yep.
So this black product here is magnetite that's seared onto the inside edge, the slowest moving water on the heat exchanger, and also the hottest part. And a couple pieces collect and a couple pieces more, and before you know it, you got a whole collection here. This is so hard that you might think, oh, I'll just go in and descale the water side of the heat exchanger, something you should never have to do in a water tube boiler. But if you think you're going to, it's not going to descale in 15 minutes. It's going to descale in 15 days. Just keep that in mind. This is so hard. And you can see a little notch right here. This is where I used a hammer and a chisel. All right, so it was a 10-inch crescent wrench and a 6-in-1 screwdriver, okay? The 6-in-1 screwdriver is now a 2-in-1 because you can't use that side of it anymore, and the crescent wrench is still usable. But you couldn't break it free. I was thinking this whole thing was going to flake off. I want you to notice something else that was caused by this buildup of iron oxide or magnetite. Look how thin the inside corner of this is, the inside of the heat exchanger compared to the outside. This is from the steam pockets in here exploding and just eroding this stainless steel. Isn't that amazing? That's why all these pinholes are down along this bottom, is because from the explosions that's gone through. And you know this is happening because of the sound it makes when it starts up cold. If you ever put a kettle on the stove, you know what kettling is. It makes that little popping, hissing sound. Now multiply that by 1,000, and that's what you hear. And on this particular heat exchanger, I was in a 4x6 mechanical room. It was so loud that I had to leave the room to hear the contractor talk to me. And he made this statement. Well, would it have made a difference? The last 3 years I had a 007 on as the boiler pump, and I just put the recommended 0011 on. Would that have made a difference? No, we write installation operation manuals and put it in the circulator sizes for no good reason at all. Of course it would. So consequently, went from there. So
yeah, it would have made a difference. It made a difference if I was taller. I could grab the glass out of the top cabinet.
Yep. So anyway, Jason, launch poll question number 3, please.
All right, here we go. All right. See, I got this all set up for you. To prevent scale buildup inside the heat exchanger, you should do the following. See, you should put the following.
And we are talking about water tube heat exchangers in this application.
Nice, clarify it. All right, make sure you have the right boiler circulator, see the IOM. Okay. Next one, make sure you have, make sure boiler water is clean. How are you gonna do that without pulling a magnet out and testing it? Use cleaner and inhibitor all day long. Install a magnet filter all day long.
Don't give me the answers. Don't give me the answers while you're reading, Jason. For God's sake.
I just love your answers. Or all of the above.
Oh, God, I wish Ted was here.
Jason, shut up.
So if Jason hasn't already given you the answer, please feel free to submit your question, your answers on that.
Everybody got it. Steve, come on. Everybody got it right. All of the above, baby. 100%. All the above. Hey, they're listening. They're listening.
That's a good thing, right? So anyway,
because I gotta go back to this. I do not want to hear anybody say I flush water through the system and I don't see anything. Never tell me you flush water through a system and you don't see anything. Doesn't matter. You're not adding a chemical to break up the sediment inside the system. So don't say you flush fresh water through it. It's not going to work. I'm telling you, unless you're doing a power flush, the only way you're going to move anything through that system. Fresh water does crap. Right, Steve?
Absolutely. Anyway, so combustion chamber, disadvantages again. The combustion chamber must be cleaned annually on propane and every 2 years on natural gas. This is what a heat exchanger looks like new. This is what a heat exchanger looks after 4 years of neglect. Notably, you would open this up and there'd just be some yellow staining on it. But in this application, you got all sorts of pellets in the bottom. To clean this, you would get our brush cleaning kit. You'd first vacuum out all of the loose stuff on the bottom. You'd slide the little plate in the back to cover the insulation. Then you'd spray it down with 50% water, 50% vinegar. If you're heavier on anything, make it heavier on vinegar. I know it's an expense that you just don't want to spend because you can go to Costco and get 2.5 gallons of vinegar for $3. So pack them up, put them on, spray it down. Use the brush with your battery operated drill. I find a 4 amp hour battery is fine. You can carry an 8 if you want, or a 9, doesn't matter. Brush it down using firm pressure. Keep spraying it and keeping it wet. You're going to help clean out the condensate drain while you're doing this. Clean the unit, and then take a membership card or a hotel key card, something like a credit card without numbers, raised numbers on it, and use that to go between the slots and make sure the slots between the tubes are open. What happens when this gets dirty like this is it slows the product's combustion from being able to go out through the heat exchanger and go around the insulation as it's designed and go to the back. So it builds it all up. It builds all that heat up inside there. And what happens is your stack temperature starts going up a lot. And this is why things like Jesus fuses blow on the isothermic shells. It doesn't, getting rid of it isn't going to help the situation. They need to be cleaned and serviced. This means that you need to have a service policy set up.
Steve, not just the Jesus fuse, but also, how many of you guys have been out? I know you see it on installation or service call when you go out to a service call and the igniters or sensors starting to move away from the burner. Uncle Steve's telling you exactly why. It cannot get rid of the heat. The burner is burning too hot, and the igniter and sensor will move away because they overheat. The Kentil steel will lose its strength.
Or you're running the unit too rich. What either or. So Jason, if you would, launch poll question number 4, please.
All right, here we go. All right. How often does a water tube heat exchanger need to be cleaned? Every year using propane, every 2 years burning natural gas, when the boiler keeps going off at high state temperature, or answer 1 and 2. That was pretty good, Steve. That's pretty good. Sometimes you got some good ones. All right, so where are we at here? 92% said 1 and 2, 7% when the boiler goes. We got some hecklers out there. 7% said when the boiler goes off on high stack temperature. So we got some. We got some guys that wait.
And the reason for the high stack temperature is because your customer will call you and say, "Hey, my boiler's not working. It keeps going off every 5 minutes. What do I do?" And you got to service it, and you see it.
And it goes back to the homeowner says, "Hey, I was gonna get it serviced last year, but my mom had something she needed done. I just scratched the appointment." And then they do it another year. They put it off like 3 years, and now you got that situation. That's how it always happens. All right, I'm closing the poll. 94 said 1 and 2. And that's how, you know what, Steve, that is a good point. That's how it happens. It's not always the contractor calls. If they're sending, come on, Steve, if they're sending a birthday card out, right? Like it. If they're sending the birthday card out and they're getting a response, but the homeowner's not committing to it, it's not their fault.
So William McKay, hi William, asked a question: will you see high stack temperatures on the PVC venting pipe? Of course you will, William. That's why we have our spectrum of PVC. Our spectrum of PVC is this: it comes white, it turns yellow, goes brown. We're increasing the temperature. From brown it goes pink, from pink it goes purple, purple then black, black then fire. Pretty easy. That's your spectrum, and I've seen it in the past 13 years in every one of those phases, which is why I'm dead set against using PVC for a venting product. It's no longer cheaper than Centrotherm. Centrotherm is less money than PVC, and it reduces your liability, but it's faster to install. So now let's talk about fire tube heat exchangers. So fire tube heat exchangers work a little differently than a water tube.
Whoa. Slow your roll. How do you mean PVC is easier to install than polypropylene?
I didn't say that. I said polypropylene is. If I said PVC, I misspoke.
All day long. Bless the Lord for polypropylene. That is so easy, man. In and out. Come on, Steve. We piped that van in together, you and I, freaking in 30 minutes.
We had for a little while when I was a rep, as a Centrotherm rep back 12 years ago, we had a little display that was beat the clock, and the fastest person on the installation of a venting system got a pretty good prize. I think we're giving away at the time a 54-inch or 55-inch TV, and the best, and guys wanted to do it with PVC, and other guys wanted to do it with polypropylene, and the guy with polypropylene did this thing in like a minute and a half. But anyway, that's besides the point. So now let's talk about how a fire tube works compared to a water tube, right? So the water tube was holding 4 pints of water if it's a Giannone, a gallon of water, or a gallon and a half if it was an Extra Tech. But here we have a fire tube heat exchanger that holds 4.5 gallons of water in the same size. The fire is in the big open area in the top. Fires down, it actually fires out off the burner, but then it's forced, the products and combustions are forced down through these tubes. The hottest supply water is coming off the top, and as the fire is going down through the tubes, or the products and combustion are going down, the water comes in, the return is circulating around it and whisking the heat off of it, taking that energy out and taking it out to the supply and making it condense inside. The reason that the fire tube became so popular many years ago, about 15 years ago now, was based on 2 lies. One lie was it never needed primary, secondary circulation, of which now that book has been rewritten and said the best practice is primary, secondary circulation. And the second lie is it never needs to be cleaned because the condensate washes the carbon out through the tubes and mysteriously no dirt comes in the top. And it's funny, but all the ones I've seen packed that needed to be cleaned in a fire tube is the top 1 inch of all the tubes all the way around from the crap coming in through the burner and the burner being set up incorrectly. Not down the bottom where it condenses, up the top. So self-cleaning is bullshit. Will they need to be cleaned?
Amen.
Yes.
Amen.
When will they need to be cleaned? They will need to be cleaned when the stack temperature reaches 30 degrees over the supply temperature.
No,
now let's look at that's how it works. Now let's look at the advantages of a fire tube. Less maintenance. Yeah, you won't have to clean it every other year on natural gas or every year on propane, but you'll have to eventually clean it. Could that be, if you have clean, beautiful air coming in and you've set up the combustion every year, you are absolutely right. You might not have to clean that for 10, 15 years, but you gotta check it to see what it's doing. The 30-degree rule, I mentioned it earlier, I'll mention it one more time. When your stack temperature reaches a point of 30 degrees more than your supply temperature, it needs to be cleaned. Meaning, if my supply temperature is at 110 and my stack temperature is at 140, it needs to be cleaned. Cool. Before you clean a fire tube heat exchanger, you will acquire the insulation that goes in the top, the gasket that goes on the burner door, and the igniter and flame sensor. It's called a gasket cleaning kit. This is the hottest part of this boiler, and I will guarantee you that you run over an 85% chance that when you pull that burner door, that insulation is going to shatter, and you're going to make this statement. I love this statement. I had a guy call me up and says, "Hey, I found the problem. I took the burner door off and the insulation was all broken. So that must have been the problem all along." No, the problem is it's dirty, you son of a bitch. Clean it. If that insulation was gone, that burner door wouldn't be there. That steel burner door cannot handle 2,500 degrees.
Steve, and the other thing is, at that point, those sensors, if you get the right kit, they now can get everything they need to replace on that boiler, and they now can bring a service kit as a service kit. When you go out, you take an igniter, a sensor, a fiber board that is guaranteed to break. You are correct about it. It is guaranteed to break after a couple years. And if they don't have it, they're screwed. They are screwed. And that's the problem. That service kit can save their butt. It can really save them from a headache.
So I do want to point out one thing. We do use 2 different fire tubes from AIC. The one on the left is the one we use in our TFT. The one on the right is the one in the FTVN. Somebody said, "Oh, that must be, the one from Korea that has the baffles." I want you to look at the heat. So down below is the fire tube on the left, the TFT. And you can see that the tubes are oval and they're dimpled, and that's 100% hand welded. It's amazing. The one on the top, the tube is still dimpled to slow the product's combustion down. There's no baffles in that. There's no aluminum inserts like a Kitsurami. No. This is not the ones that you see other people have. They look round, but look, they're still squished down below and they're still dimpled inside. This is 100% made by a robot, which is why everything is symmetrical on it, so the robot knows where to weld. I've never in my life seen it. I've never once seen a cleaner weld in my life. What's that, Jason?
Once you open them up, bud, you can tell that that's not baffles. You can tell they're not baffles. You can tell once you cut one open, When you cut your first one open, you'll tell they're not baffles.
I
That is
got-
all built in the refrigerator.
I got blamed last week for, they said, well, that has baffles. And I'm like, that's not a Kitsurami. That's an AIC.
skating.
It's
Okay,
Swiss
I'm
tubing.
skating.
So,
I'm skinny. I'm 6 foot tall. Yeah, okay. If you believe that, I got some swampland to sell you too.
in your
With a
dreams.
bridge.
All right. Anyway, so there's a lower pressure drop through these. So you need a smaller boiler pump. You know, you guys might call it the primary pump, the secondary pump. I don't care. I call it a boiler pump and system pumps because the primary loop's no longer there. So boiler pump, system pump, the boiler pump's much smaller on these because it's a big open cavity. There's no restriction on the water. Higher mass, which means it gets hot slower, but it has less hunt and pecking. It's much more accurate on its temperature. The life expectancy is longer on these with the asterisk, and the asterisk means as long as it's well maintained and you have the proper water quality. Disadvantages of a fire tube: they're larger in size. Yeah, they hold more water. They got to be larger. They cost more to produce. Yeah, you're going to spend a few $100s more for the least expensive fire tube compared to the least expensive water tube. And it takes minutes, not seconds, to get the temperature. So to go from 70 degrees to 180 degrees isn't 10 seconds. It's more like 45 seconds or a minute, minute and a half. There's acceptable to failure by magnetite. I want that to sink in for a second because I'm going to show you something here. Here's the inside of a heat exchanger, right? So far, so good. That's the heat exchanger on the right out of the TFT. That's that insulation I was telling you about right up here at the top, the insulation and the burner door gasket that's not shown here. And that's magnetite. That's magnetite buildup on the bottom of that heat exchanger. Now, I mean, that looks pretty critical, but let me show you another one. So there's a heat exchanger, and look at all that magnetite. This particular boiler, if you think this is going to take years to do, this particular boiler was installed January 10th and failed March 16th of the same year.
Damn.
So this isn't bullshit, folks. I always thought I was looking for Elvis. I remember when Dan Holohan, good friend of mine, wrote an article about oxygen infiltration, and he kind of thought it was bullshit, but it really isn't. And he's agreed to that, and he actually rescinded that whole article. But he called the article looking for Elvis because he thought you're looking for a pig in a poke. And here in the United States, we never thought about this stuff ever until we started having failures. And now every manufacturer, and I can say this, every manufacturer, every condensing boiler manufacturer is preaching water quality, water quality, water quality, water quality. So,
amen.
Folks, this is what happens to the tube sheet because this does not collect evenly on the heat exchanger. Wait a minute. This does not collect evenly on the heat exchanger. It doesn't. It collects in areas, which insulates certain areas from the heat, so it can't get the water to transfer the heat. But now I want to show you something here. You can't see it real well here, but let me zoom in on it.
That is a great picture.
That's what it looks like. You're not melting the welds, you're cracking and stressing the tube sheet. I had somebody say to me, well, I'll just get somebody welded together. Well, that's great, but all the magnetite's still inside, and it's just going to crack someplace else in hours, not days, not weeks, not months. In hours or minutes, it's going to crack again. So you can't just go weld it. So this is how they fail. When we ask you and you call us up and say, oh, you know, I got a blah, 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 leaker, blah, 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 water down the condensate, blah, blah, blah. And we say, well, the boiler's not working anyway. Take the burner door off and take a picture. This is what we're looking for. This is what we're looking at.
Uncle Steve, that's a nice picture, an example. I like it. I liked it. That is nice. That is perfect. Can you go back one step? I want to go back. Now, do you see the discoloration on the discoloration rainbow, the high temperature rainbow? You see, you got a bunch of colors. You remember that chart we had that shows the different temperatures and the different stress on the heat metal? This would be a rainbow right there. Oh, this is a perfect. We could do a color cut. We could draw this in crowns. I love this.
I almost destroyed my my iPhone taking that picture. So anyway,
missing out there.
Poll question number 5. You would, Jason. Poll question number 5.
All right. Is magnetite iron oxide harmful to a fire tube heat exchanger? Yes or no? This should be. Damn, they're quick. They're quick. Hold on. 89, 92. Yes. 7. No. 94. Yes. 6 now. I had somebody pull an answer back. Had to have pulled one. All right. So that is a very easy one. Yes, it is very harmful. And 94% answered it correct. 6 answered incorrect. Hey, Uncle Steve.
All right, boys. So
Ooh,
I just
like that picture.
I got like 4 or 5 more slides and we're done, but I need to talk about water quality and water treatment. So you might see that tonight I'm sporting my Fernox shirt because last week I spent
Nice shirt.
I spent 3 days with my buddy Eric from Fernox, who I absolutely love, and he enlightened me about a couple new products. But first, I want to tell you this: that basically all these chemicals are the same. I want you to stop calling the cleaner the cleaner. Although it says cleaner on the can, it scares people. They think you're going to go and put holes in their pipe because they're going to clean the dirt out and the pipes are going to get holes in it. It's not. The cleaner is actually an emulsifier. Think of this. The emulsifier, all it does is pick up all the iron oxide, all that black shit, all that stuff that smells like death when you get it on your hands. It gets in your calluses. You can't get it out. The shit that my original master plumber who taught me this shit said, kid, that black water means that the boiler's great. It's good stuff. That's black gold because that means the boiler's got no leaks in it. If it was leaks, it'd be all rusty. So anyway, for a cast iron boiler, you got wet legs for it to go down into. You don't have wet legs in condensing boilers. So F3 would be your cleaner. F1 would be your protector. So the way that this works, and that's the same with the 80 product to the right, the MC3 is the same as number 3, the MC1 is the same as number 1. They offer it in Jiffy cans. All their Jiffy cans now are good for 32 gallons because Fernox made theirs bigger, like 80 does. They all have magnetic filters. They all have spinnable, so you can put them vertically or horizontally. It doesn't matter. They come ball valve options if you want them. So they're available. You just have to watch the flow rates on the magnets. Important. Always watch your flow rate on the magnets. Don't overflow a magnet. All right, now, meaning if the magnet's rated to 14 gallon a minute, do not go over the 14 gallon a minute or can't get the magnetite out. All right, so you put in the F3 product if you have an existing boiler that's there, F3 product, and you put it in there if you have heat for 4 hours. If you don't have heat, say it's summertime where the burner's out, put it in there for 4 days with circulation. Clean it and flush it out after or within 14 days. No more, because after 14 days, everything starts to settle out. Then when you put the new boiler in, you get all the air out, you put F1 into it as a protector. 1 can covers 32 gallons. You cannot over-treat the system. Now, the question comes to me all the time, hey, Wheels, what happens if we're replacing the boiler because the boiler bottom blew out and we got to put a new boiler in? What do we do then? Well, then you put a magnetic filter on the return and use the protector F9, Fernox F9. It's a new product out. It actually has 2/3 F1 and 1/3 of F3 in it. So it'll emulsify, it'll get all that crap up in a slow way while it's protecting the system and bring it all back to the magnet. What does it mean for you? It means you're coming back every month for the first 6 months, or at least the first and second month, and checking the magnet. If you go in there and the magnet's not packed, then make it 2 months. If the magnet's fully packed, make it every 3 weeks. And you'll see that eventually it'll get less and less, and you can make it an annual service to clean that magnet. All these guys, 80, Boiler Mag, Fernox, they all have videos online to see their magnetic filters and their crap. So it's all there. Yes, Jason.
I have a question for you, Uncle Steve. If I have antifreeze, is it going to be different? Is it going to be very critical that I check the inhibitor every year? If I have antifreeze in a system, do I have to check the inhibitor every year?
Well, you should check the inhibitor anyway, because the inhibitor will actually neutralize or bring the pH up of your antifreeze.
Thank you, because I asked that question because I wanted to open up the door. Guys, when you have antifreeze, keep in mind, if it's a special antifreeze, you must use their inhibitor, but test it every couple years because it loses its viscosity and it loses its intensity to inhibit any problems in the system. So I'm telling you, check it. It's an issue. Guys, remember, it trains air, so when you use it in large content, it creates issues. So check your... Yes.
So Bentley reminded me that the iPhone picture I took must have been crap because I used his, and he said that's his picture. So I'll give him I'll give him the.
Well,
the
whatever
credit
it is,
So
it's a nice freaking picture. I gotta tell you, that's
anyway.
probably the best freaking picture I've ever seen.
So Malik asked a question: why should he put the magnet on the return? Because on the return, it will keep all the shit from getting back to the boiler and the boiler circulator, and it'll also keep it from getting to your circulators on the supply. That's why you put the magnetic filter on the return. If you have it on the supply, will it work? Yes. It's better on the return. You can put on the supply, better on the return. Now, they do make a SEP 4 low loss header that goes right in the middle of all of it. That's the SEP 4 filter. Everybody's coming out with these things. It's a low loss header. It's a tube in the middle with a supply and return on the other side, one for the boiler, one for the system. Some have a long insertion magnet, some have a magnetic wrap around it. All of them have an air vent on it. They're a dirt separator, a magnetic, an air separator, and a complete filter, a low loss header. So they're great. Anyway, so thank you, Bentley, for bringing that up. Oh, and to answer the question to William McKay, did you answer that? The brown is the hot spots. Well, the darker brown is hot spots. The purple was really hot spots. Anyway, so not to be used for domestic hot water. If you remember correctly, you could use a water tube for domestic hot water because it's rated at higher pressure. It's rated to have higher velocity through it. We want higher velocity through it because it holds less water, so we can make them as water heaters or as boilers. But let me show you what happens when you try to use a fire tube as a water heater. The calcium burns right onto the top of the tube sheet, just like it did with the steel, with the magnetite. Oh, wait a minute, this isn't bad. Wait for this one. You ready? You ready for this one? Here it goes. Ready? Ready? Here it comes. There's my cutaway. Folks, this boiler that you see this picture of actually melted the burner door off of it because there was so much calcium in it, it covered both the supply and the return thermistors. And it didn't know what temperature it was. The thermistors thought they were 70 degrees, so the burner kept firing, and it literally melted the insulation and then melted the burner door. So this isn't something that you want to play with. You don't want to have system leaks.
That is
You
probably
want
one
to
of my favorite pictures you have.
You want to I usually don't show it.
I love that one. I've seen it before.
So anyway, so if you would, Jason, launch question number 6.
Oh, that
the
was
last
good.
question of the night.
All right, here we go. That was a great picture. You should show that one more often. How do you prevent calcium buildup? Let me close the little box here. Calcium buildup in a fire tube heat exchanger. Do not use it for direct heating of domestic hot water. Make sure there is no leaks in the system. Use the system saver filter. Calcium and sediment, no problem.
No, that's calcium smalcium. What do you mean sediment? Would you read these things, please?
Dude, you're somebody's question you come up with or wanted to.
Calcium smalcium. There's no such thing as calcium problem here.
That was pretty good. Oh, I missed you. I missed you this week. 8%. 8% say do not use a heating. Do not use direct heating when domestic hot water. 81% wanted to. 6% use the system filter saver, and then the other 6 calcium smells here. No problem. Oh, that's funny, dude.
Like I say,
The
the 6% that said system saver were our A.O. Smith representatives out in New York City, but we won't talk about that. So, all right, end that poll.
No,
so I can't end. I can't end on a bad note. So end the poll. There we go. There we go.
No, hold on. That's as bad as making a guy go out and put a T-Rex costume on and come in a bar.
Anyway,
right,
so I can't end on a bad note. I can never end with destroyed heat exchangers. We are the only manufacturer who will show you how these fail. I am the only manufacturer, I believe, that carries a 4.5-inch diamond cutoff saw and will actually come to your location and cut the heat exchanger open there, because I want to save the $250 in 3 months to get the answer back from us to say, sorry, it's not warranty. So I love this because I was talking to a bunch of plumbing, heating, and air conditioning contractors
Yeah,
last week. We did 5 shows last week, but we were talking about lowering boilers down on 2x12s. And here's a guy in the snow because, folks, it's snowing in some of our territories, and it's going to snow more this winter than it's ever snowed. But here's a guy using his Jeep to pull a cast iron oil fire that looks like a 3-section Wild McLean out of a basement. So it's pretty funny.
Kind of wedge he's pulling it right at. I'd like that.
Yeah, but then I have to end on a positive note.
Thanks for watching the video today. If you'd like to check out more videos, see the link below. Don't forget to like, share, and subscribe to our channel for all the future updates. And also check us out on Facebook, LinkedIn, and Instagram.